Okay, here's a third example. This is a mass rotating a horizontal circle with a string that makes an angle. So this is one of these angle kind of questions. So you kind of have maybe a pole here and a circle or string with a mass, and the mass is like going in a circle like this. So that's the center of the circle. It's kind of accelerating towards the center, and there is tension there. So if you do a force diagram, your force diagram will look like this. FG, FT, and this is 20 degrees. Okay, so that's the force diagram. And FC is coming from the horizontal component of FT. Okay, so the first question is, what is the tension of the string? So we'll probably need to know AC. Can we figure that out? Yes. Can we? Not yet. However, this is what we do know. We know that that component there, the vertical component FT, has to be balanced with FG. Otherwise, this ball would either be accelerating upwards or downwards. If FG was bigger than that, it would be accelerating downwards. If it was smaller, it'd be accelerating upwards, but it's going in a horizontal circle. So this thing here has to be balanced with that. So FG is equal to FT sine 20 degrees. So FT is equal to FG divided by sine 20. So that's FG is 500 kilograms times 9.8 divided by sine 20. So 500, 9.8 divided by sine 20. So we get 1.43 times 10 to the 4. Okay, that's the tension. Super. What is the frequency of the mass? So if we're looking for frequency, this is what I'm thinking. If we're looking for frequency, if we can find the period, we can get the frequency. It's just the inverse of the frequency. So we're gonna try to find the period. So first I want to do is find out what FC is. So FC is equal to FT cos 20 degrees. So it's the horizontal component of that is FC. So we already got the FT, so that's 1.43 times 10 to the 4 times cos 20. So 1.346 times 10 to the 4 newtons. I didn't do any rounding. I kept this number in the calculator. If you don't want to do any rounding, you could also use your tan law, like FG over FC is tan 20 degrees. Okay, we got FC. And since we know FC is equal to MAC, we can calculate AC. So that's FC over M. So that's 1.346 times 10 to the power of 4 divided by 500. So the acceleration is 26.93 meters per second squared. Okay, AC is 4 pi squared r over t squared. So t is equal to 4 pi squared r over AC square root. So it's the radius is 0.4 meters, and that's 26.93. So 4, enter, pi squared times 0.4 times, and I'll divide that, take the square root, I get 0.766 seconds. So then the frequency, 1 over t, So that's 1.3 revs per second, which multiplied by 60, not that it really matters, but I'll do that anyways, that's 78 RPM. Okay, what is the speed of the mass? We can use a similar thing. We already know the AC. So AC is V squared over R. So V is AC times R square root 26.93 0.40 square root 0.4 square root. I get 3.28 meters per second. And we can double check that. The circumference divided by the period should be the same thing. So the circumference was 2 pi r, so 2 pi r is 0.4, so that's the circumference, divided by 0.766 should give us the same number, or close to. Yeah, sweet.